I started in OSS in around '94. And one of the first challenges was fault management where I grew up. And you were mentioning streaming now. I remember that the operators at that time, they said, oh, we cannot miss any event. We need to collect all events, right? After 2 years, they said, oh, can we do filters now? Because it's too much, right? So we filtered, but we didn't know what to do with the rest of the data, more or less, right? So in the meantime, now we have streaming, we have big data, so we just collect everything. What the heck do we all do with this one? And the matter with artificial intelligence, hey, pattern recognition, yeah? You do not necessarily need to know exactly all the structures. If you take 1,000 times a similar photo of a wonderful landscape with sun, right? And then you have one photo where everything is white, so the system can tell you, oh, alarm, alarm, there's something odd. Now, some clever guy may detect, oh, it's winter. It's just because it's snow, right? So then you can tear down, and that's a way of learning here. But you see, the recognition of problems has to completely changed. It doesn't rely, since quite a long time already, just on humans, right, which count alarms, and what the heck do they mean, right? They want to avoid it. So it was a little bit funny. You mentioned the streaming, indeed. It's really interesting how that all changes. Okay. Now, coming back to the topic, means of automation. You saw there are several normative documents where we really sit together and say, well, this can be something what everybody really needs. We wanted, on the other hand, also to take the freedom, because we have many vendors in, operators in, which have a learning, which have already running automation. And we said, okay, let's have a look at that and collect it where it's really valuable and do it in a separate report. So it's an informative report, how you can do things, right? So, and we are looking very much currently on orchestration. There's a focus on that one today. But also you see side effects if you have autonomic networks, right, which does things on its own, right? What side effects does it have? Things like that. So it's useful autonomy. That's a step into the story, more or less. Let me explain first a little bit the problem. Farney was great in explaining the uses as scenarios and the use cases which you have as requirements. I tried to make a more simple picture here. And that shows, here we have an edge, right, which is a new kid in town. We have something centrally in a cloud or in a central data center. And we have a car outside here. It's an IoT case if you want, okay? So now, what happens when this car is driving and with 5G? What is 5G doing here? So 5G first has mechanisms that somebody using the communication mechanisms here, right, is able to register here. This is access management function and so on. So it's a core network service. How I was yesterday explaining about the core and the autonomy of the core. So there are things happening in the core. Now, what means a slice? A slice at the end provides connectivity to that core, but even better, there's this vehicle to something application which controls the car. Hey, which controls the car. Ultra reliable. So we need a slice which is able to cope with that car in ultra reliable way because it's really controlling the car. That will be the future over the network. Hey, do you trust on that? Yeah. So it keeps the traffic, the user plane traffic, between the car on the edge. It doesn't go outside, right? That's the purpose what slices is for, one of them. So, and now there are also different communications. You have a communication for registration, another one for the PDU establishment, another one for the user plane, and so on. There are different communications. Look, you need to understand there is more than just plugging network functions to network. The point that you and me have a telephone line between us doesn't mean that we talk to each other. We need to have a reason. And this is business logic, business reasons. So setting up VNFs also combined with PNFs, so there's never a green field, so you always have this combination. You have always hybrid cases. So, and plugging them to networks means nothing. Yeah, they're up and running. That can be done since a couple of years, since 2014, since NFV gets more matured. But the business logic is still a challenge on that. Now, you can imagine there are other cases for slices, like here this one, you want to give your kids your entertainment, so you do some video streaming, right? Very different purpose, very different needs for that slice. Another slice is just collecting maintenance statistics, so not that crucial, not that reliable necessary. So you have 3 slices, all very different quality, all very different intent, right? So, and that's something what we want to do in the future. And these things pop up, come down, maybe roam through different edges and so on. So you see the dynamics which we have in 5G. So to make a more simple picture, here we have our car. Essentially, slices have a sort of orthogonal relationship with the underlying common core network function and so on, right? So you have orthogonal relationships. When you look at usual hierarchies like CFS, RFS, resource, that doesn't work anymore. We do not have simple hierarchies anymore. And if you now imagine how many 10,000, 100,000, how many slices you may have with IoT, every application may have a specific slice for itself. We don't know yet. Yeah, but 5G enables this. So you have millions of network functions dynamically being started and stopped, whatever you need them for, right? So, and then imagine now you have a heterogeneous environment. Some stuff comes from Nokia, others from HP, others from Huawei, etc. That all needs to work together. And you have different versions of them. Hey, somebody puts a new version of the network functions, so all others need to adapt on it. How does it all relate? So you cannot cope with this mass of dynamics with the existing means today. Well, that comes back now as an introduction to the to ZSM, at least what we looked at. Now, when we talk about automation, automation as such is a big ball. Well, it's a different ball, but there are different maturity levels. You can automate things. Once you know what to automate, you can automate things. You can automate everything, right? You may take a year. Then you have it automated in a way. But you can only automate what you know what you need to automate. So, but there can be situations which you cannot foresee. So you need to give more autonomy to your system that it can decide by itself in a way. So when we look at such a fish swarm here, right, there is no director in there. There is no central orchestration. This is what is called a choreography. There are players in the swarm, and by some way, they orientate to each other. This is an autonomy example. Yeah? So it's interesting to compare that, also choreography versus orchestration. But there's a combination necessary, probably. Okay. So one thing what the report claims first, it makes a differentiation between automation, awareness, adaptive, autonomous. So you need all these 4 components finally, or let me say this is the highest maturity. So automatic means you have programs which provide proficiency to execute systematic existing tasks. So you can simplify your life on that, yeah? But that doesn't mean that the same automation is able to do tomorrow a complete different slice, to come back with that example. So second, it needs to be aware. So anomalies, faults detection, and so on, you need to be aware on that so that you have an influence. What is the current situation? You need to have the results of the automation, right? Finally, you want to adapt your system, so you need, again, different means. So you can adapt them, and once this is all playing together, then you can say you're fully autonomous. So just as a reference first, be aware where you are. When you look at these self-driving vehicles, like some Tesla, for example, is trying to do, there are very, very dedicated different levels on that one. We can be a little bit more simple here, but just be aware what your system is able to achieve. Now, a little bit of much text, but I consciously copied stuff from the contributions which you have for the report. It's talking about a comprehensive automation. One is an automation comprehensive. And comprehensiveness means, for example, it is vertically, it goes up from the customer service down to the lowest level resource, or even maybe even on an API level. Horizontally, because you cross different technologies, license cross different technologies, edge, cloud, core connectivity, and so on. You want to be repeatable and reusable, so essentially it should be agnostic what it's controlling, so you want to reuse the mechanisms. You cannot invent everything, something new. And finally, it needs to be dynamically and so on. There's an important thing. There's function automation, there's process automation. Function automation we have since long time in a way. Now, and we have typically in service-oriented systems, we have way to combine functions, and we can automate these. When it comes to processes, we typically still have, a process modeling, a process engine, versus I wanted to say an orchestration engine, but you have three places typically in such system. You have the service, typically in a hierarchy, which you want to achieve. Second, you have policies, which help you to reach the automation. And third time, you have workflows, and that needs to become in combination. Already a tricky thing, but that's still the thing how orchestration usually works today. So process is the workflows, function automation is the functional part, and there's basically a third dimension you can say, which is the service you want to achieve. Okay, so the status of the report today covers these areas. It looks, for example, at autonomies within networks, self-optimizing networks, do things on their own. Can I get hold of that, or am I completely lost? The operator wants to keep a control, of course. Then how to govern that, right? How to govern such autonomous functions, right? So what do I need for this? And then finally we come to the point, how can we really automate it? So going into the zero-touch operations automations. And so also very important, I can automate everything if I have 10 years of time. The problem is I don't have that time at all. New services pop up every day, and it will increase exponential growth of services. We don't have the time, so this is the most crucial thing. And we probably also do not have the time to wait for standard always until they explain us how we can do that now, right? So we need to start probably at a different level. Okay, let me touch a little bit about service stability and governance. There's the time, that's good. Service stability and governance, what we look at. So when you have, simple example, you have an energy saving function and you have a load balancing function. They have a native conflict with each other because the load balancing cannot start the shutdown machine that fast as it likes to do, while the energy function is always trying to shut down things, right? There's a native contradiction, and there needs to be a way to balance that. So, there are studies existing in concrete projects, etc., which define how that could work. Yeah, we can monitor the behavior. We're looking at metrics which we need to bring it into a relationship. So we need to detect conflicts. Then we calculate what is the best way to control, and for that purpose we need to be adaptive. So we need to know what can be adapted in this function, and then control the overall system in a coordination. That's essentially what we need now. So coordination provides conflicts detection, algorithms to ensure coordination, mechanisms to control, and so on. I mean, I have been asked now, is ZSM really inventing something new? My problem simply is that I do not see the abstraction of all what we need. ZSM is very well abstracting things and what we need. It doesn't necessarily preach you, this is exactly the way you need to do it, but these are quite fundamental things which you just write up, hey, this is what we need to control these things, right? So ZSM maybe not that prescriptive in how to do stuff, but it tells you, hey, look, this is the concepts which you need to look for. I will solve. So we're coming a bit closer to how governance of not only networks, also services can happen. And so essentially the idea is that the operator, the humans are freed more for looking into future networks and services. So what we need is a governance framework which unloads the human in the picture. And so in the years, now there's a history, I come to the history a bit. When we do a business translation, and we can say here on that level, we have an intent, we have a business intent. We want to have the connectivity at a certain bandwidth or whatever, this is the intent. Then we have policies to control that and to deassemble that in services, and services can be deassembled finally into resources. So we have policies which control and coordinate that on the different levels. So we could use TMF, ETOM notions like products, service, and so on. But finally, I say it's not that important to differentiate that, but today we have quite different means on the different levels. There's a governance framework which typically needs to understand something what comes from a human. It could be the customer at the self-service portal, touching it down into first, set up the autonomic functions, you can say network functions, given they are more autonomous, set up, deploy them, connect them. But then for enforcement, right, we need to understand really what does that customer want. As I said, it's not enough just to put the telephone line between us. We need a reason to talk, and we need to adapt this based on the concrete context. So then I have the enforcement of policies in that way. I'm a little bit, free in the interpretation. I know very well it can be much more specific. Now, I mentioned service. You have the hierarchies in mind, CFS, as that concept is well known by everybody. Now, I want to be more consequent in saying everything is a service. So that part is very well known. When you go now deeper, so then a service orchestration classically stops here. In the best case, it has a clue about the resource. But when I have a virtual function, a VNF, I call my NFVO to start the VNF. It's a service. So for me, it's nothing else than a service. In that sense, a PNF is deployment like a service of the workforce management. But for me, as an orchestration, it's a service. Again, I hope it's already set up before I touch it, because then I want to touch the functions, the business logic on the PNF as well as on the VNF. At that level, I don't care if it's a VNF or a PNF. It doesn't matter. It just needs to run. Yeah? So I also have networks. So all these things are just resources. There's a dashed line to indicate, hey, look, this is an abstraction. It can be more concrete. Late mining. I can have a connectivity which is a slice. I can have another connectivity which is a VPN. As a product manager, I don't care. I just say, my product needs a connectivity. And that's what I want to model first. And then the service designer comes and says, oh, I have here a nice 5G slice for you. Okay, plug it in, works. So imagine, just this thinking, the product manager comes in and says, I need a product with this and this connectivity. And there is a service designer which has already models, and just plug them in, draw a line between. This is what is for us also a way to model in the future. I come back on the modeling aspect of it. Another point is quality indicators. Still, there is most times a silo between assurance and fulfillment. So we think the qualities must be part of the model from the beginning. And I set them up. I need to set up something in collection system that I say, hey, if this quality here appears, and I know my service has a problem, I just manage it together with the service. Okay, coming to the business goals of digital service provider. You may ask the CTO or, well, the chief marketing officer is probably asking for self-service first. So, the CTO, the product manager also said, I want to compose new services. Like I said, I need a connectivity, but today with this technology, tomorrow with this technology. I need to compose it. I want to compose it very fast. So finally, agility to achieve shortest time to market. I want to have it running in a few months. Like Fadi with Johan, right? You were talking about the time frames. When it comes to enterprise services, like, customer premise, virtual line, and things like this. So then there were timelines of 9 months in average from customers which we have. So this is shorter than a big core, right? Of course. And they want to go down to weeks or days to introduce new products. So this is definitely was most of the challenging things. So now I'm coming to the intent-based, Cliff. You were asking about intent-based API. This is just one aspect, yeah. An intent as such is probably rather easy to explain, but what it means in the machinery is a complete different question. So intent-based modeling, networking, orchestration, and they can all mean different things. Yeah. So is a new approach which pops up since a couple of years. But let me look into the history a bit. some fundamentals, policy, intent. Essentially, an intent is nothing else than a declarative goal. Yeah? So I want to have a connectivity at that bandwidth. This is a declared goal. Okay? I do not say how. An if then else is an imperative policy. So this is not intent for sure, right? So policies govern the choices of behavior of a system. That was already said in 94. So long time ago. So we do more with policies. And there were many things, and policies were maturing. This statement from John Strassner was 9 years later, so it's already more sophisticated. You see a bit the history here on that. So why do we care? I mean, why do we look at policy? The point is really the autonomy. You cannot expect that if it's devices in the network, or network functions, now what, are completely autonomous. You need to have some governance and some coordination between them, and then you create an autonomous system, right? So, in any case, policies are relevant, are really relevant, and here I come a little bit more with the history. Morris Sloman in 94, as I said, policies are rules governing the choices of the system. Strassner made it more elaborated, I would say. And then in 2004, there was a very interesting study from Arasha Bandara, Emil Lupu, and Sloman was also participating in that, I believe. Goal-based approach for policy refinement. And they have, based on a certain language, numerous calculus was it called, I believe, on a certain language, they have redefined how I structure and combine services, make dependencies across them, and have rules. Do I go left, do I go right, and so on that way. You mentioned in your speech about Prolog. There are languages which are simply more suited in doing such kind of things than others, okay? So John Strassner said, okay, this is all fine with this policy stuff, but we have Dan and G, we have SUPA, fantastic stuff, yeah, but it's still awful complex. So we need to have something more simple. And he said, hey, we need intent. Yeah? So what is intent? And then he came up, Dave Landro, interesting, he said that before, 2015. Dave Landro has one of the most famous speeches about what intent is, done in 2015. It's about the what, not the how. So he's not speaking about technology here at all, not speaking about APIs, etc. He's saying what intent shall give you. So ONF has done then a very practical approach. ONF has done this intent northbound interface. Essentially, this is not much more. It defines key words like a known language and says this is the abstract language to build networks. Was proper, just works only for networks. So, and I do not want to be fixed on the keywords. Yeah. Tomorrow I have a product which looks completely different, which is not a network, which is something different. So I need to do something more. But it was a good start. Okay, various vendors in the meantime come with intent-based networking. I consciously differentiate here a bit. Networking, that's where intent-based was first grown up. I'm speaking for HP. That's the reason why we're in ZSM. We bring in something more, which is agnostic of what it is. And I've changed a little bit for ZSM. I've changed that picture from before a little bit more. It's more flexible. And also the language is different. Yeah, but I come later back on that. Okay, this is here a bit repeating what Dave Landro said in 2015. Yeah? Intent is invariant. That means whatever happens in the network, the intent stays valid. I cannot disrupt that. Yeah? So it is portable. So heterogeneous variants, etc., should not play a role. It is composable. So any combination of intent-driven services. And here you see, it's not just the CFS is the intent. Intent happens at every level, So, and then it provides context so that the system is able to find a path even if nobody has ever defined a workflow for that. So take the example of a navigation system. You want to go from A to B. You have no clue where to go. If you ask the hotel, he will give you exactly 3 workflows from the airport, by train, and with a taxi or something like that. So 3 workflows, you have no other chance. What about traffic jam? What about the plane crash? Well, okay. So the navigation system knows all the possible roads. It needs to know the roads, of course, but it needs also to know what is the shortest way, what is it now at that time, is there a traffic jam, is there construction, whatever, and it guides you, depending on the situation, complete different situations. And this is against any workflow thinking, right? So, and intent-based approach can avoid these fixed workflows. So you get more tangible. Now I speak for HPE, but this is what we brought in ZSM. We created the notion of dynamic service descriptors. Originally, they were called declarative service descriptors because they do nothing else. They declare an intent. But I have them for everything. Every little object is a descriptor. If this is just a VNF, or if it's even related to the creation on an API of something up to the CFS, we don't care. The system doesn't matter at all if you call something CFS, RFS. It's just for the operator's view that you recognize, this seems to be something high level and so on. But for the machine, completely irrelevant. So what is missing in the existing languages, or where they need to be augmented, so is basically a certain relationship, inheritance, for example. There are languages today, service models, which do not support inheritance. So here I can say, hey, on a high level, I need a connectivity. What connectivity is, I decide at a later time. Okay? So these are mechanisms which are not easy in typical languages, so we have to extend the language. So policies is behavior. Yeah? Give the single descriptor a means to decide. When you're at a crossing, you go left or you go right. So the single point, the atomic point, needs to have ways to decide go left or right, and that creates a behavior. So, and put that all now in a graph together. So it's not a single hierarchy anymore, so it's really a graph. Making that, yeah, I'm almost done. Making that basically into a machine. Model design replaces workflows. So what we want to have is basically here. You have the inputs, expected changes, a new order, something, a new firewall, new rule, whatever I want to have. Unexpected changes in the network. Somebody plugged a cable and suddenly the IP connectivity isn't there anymore. I have violations and faults, so I observe different things. Whatever comes in, there is a generic engine which compares the is status with the to be status, looks at its map, the roads, and the current status, and decides then what to do on the fly and generates those actions. So, and those actions can finally be executed by subordinated domain managers. I have specialists for things. I do not need to do everything the same way. There may be specialists for things. I have controllers, I have network functions. It's not fixed. Yeah? But the concept can be used on every level. That was basically what I wanted to speak about as a content of the concept. And here coming back to the navigation system. So that was, this is Las Rozas. It's close here to Madrid. This is where HPE has an office, right? And when I looked this morning here, right, the roads are like that. Normally you need 20 minutes to go from that to there. Today it would have been 1 hour. Okay, so 5G requires to cope with all these with all these much higher dynamics than ever intelligent software can do. So that's and the report gives examples. Concluding, right? What we have in today, the paper differentiates the different maturity levels. It addresses the areas of highest impact. I'm still missing contributions for machine learning stuff and so on that will go in over time. The paper is currently going into a stable draft, but it's not finished. There are still contributions approved, but not in. So when you look today at the paper, you find some of the stuff not in. There will be in the next days. And we collect further contributions. The publication, you can access it. You have seen already the links. You can access it. The publication formally planned for around September. Okay.
Wow. Thank you, Andreas.